Oh, good evening, or good evening. I'm already ready for the afternoon. So I am the individual that comes to you right before lunch, and I know everybody's their stomach's starting to growl, and if they get real loud, we'll just stop and call it a day. But we're going to try and get through this fairly quickly. Just keep in mind that this evening, Dr. Marks had mentioned, at the very end, I'm going to show you some samples of some wiring. I'm going to call them wiring diagrams rather than wiring schematics. It's probably a more accurate term for that. And the session this afternoon, or this evening, I should say, is going to show you how to do that. It's not complicated. It may look complicated when you see this, but it's a very simple approach. So I'm going to invite you to do that as well. Although I'm right up against the same time with Dr. Marks doing a question and answer, so we'll see how that goes. Mechanical drawings and wiring schematics, why you need them. The nice part about where I come in this particular session is that a lot of people have already mentioned a lot of the reasons and benefits for doing these things. So the nice thing is here is I just get to kind of reinforce a lot of things that have already been said prior to this. Lessons learned. So we're going to start off with, first off, I'm Brian Coleman. I'm the advisor for what is now the Somerset Independent School District, which are the solar jumpers. When I started in 2019, I was with the Bath County team, which was the first team out of Kentucky to ever attempt this. And when we came, all of these things that they were talking about, the things that you don't want to do and stuff like that for in the mechanical and electrical, we did them. So when I'm up here, I'm going to show you some things that they worked out, some things we didn't do that we should have done, and things we did. You'll get it in just a second. Lessons learned. Poor to no mechanical drawings, which is basically the first car that we built. Our mechanical drawings, we attempted the first time to do the mechanical drawings as we were building the car, and things get out of order. Sometimes you're building the car and then going back and trying to do the mechanical drawings. And why do I mention that? Because I can almost guarantee you that if you're new, you're probably in that phase where your mechanical drawings aren't finished before you started your car. Or you didn't have a completed post. And I see advisors doing this number right here because you're probably trying to tell your students you need these drawings beforehand. I'm telling you, I'm reinforcing what they're saying. You need these mechanical drawings at least to a certain point before you start production of your car. Because if you have not thought out the entire process beforehand, it produces all kinds of other problems for you. You will constantly be in a build and rebuild cycle. By the way, I keep seeing people are taking pictures. These are going to be posted on the website. You can download all of these presentations. A lot of them are already there, so you don't really have to take the pictures of everything. You can just take notes, and all of this stuff will be downloadable for you afterwards. But you're constantly going to be in a build-rebuild cycle, and the reason being is because you don't have a real plan in place. And so you're kind of feeling it as you go, and then you realize, oh, that doesn't work. Or that was a poor design because we forgot this section over here, and they're starting to conflict with one another. Significant increase in frustration and level for all, because what happens is you have groups coming in and they're putting things on the car, and then they're coming back, and all of a sudden you're having to take it back off the car because it didn't work, and people are getting frustrated because they spent all that time fabricating a piece for you, and lo and behold, you didn't take into consideration how that was going to impact another section of the vehicle or the electrical system or whatever the case may be. And so your constant rebuild cycle gets frustrating. Significant loss of time and resources. The first car that we built took us 1.5 years to build, and we literally were finishing the brake adjustments when we arrived here that day. Now, we weren't like, you've had some individuals mention that you don't want to show up here with your car in pieces. That's a bad move, because one of the things they keep emphasizing is that you want to be able to test your car before you get here. If it's going to break, you want it to break at home, where your kit is, where your people are, where your resources are. If that's occurring here, and it is going to happen to some respect, but you don't want your initial things to occur like that, because it's going to be much more complicated for you. The first year we came, there was a car that was sitting beside us, and I don't know who it is, and I'm not going to say it, wouldn't say anyway, but let's just say that their electrical system had wires going every possible direction, and then some that we didn't even know it was possible to send them that direction. That car did not pass scrutineering, and it was because there was no system to their car, both mechanically and electrically for that, and they were trying to finish their car while they were there. Year after year, it's very discouraging to see teams come in, and they're really excited to race, but they're still trying to put pieces on their car and get everything going, and they don't get through scrutineering because there simply just isn't enough time to do that. You lose a significant amount of time and resources if you don't have a plan, and your plan, in large part, is your mechanical and your electrical drawings. Many very late nights and mornings. This first year that we built this car, and you'll see down there the picture, and that is the frame that we built the very first year. That was our little classic car that we built, and that's only about 3/4 of the frame. We actually added a lot more to that. That car weighed 1,246 pounds. Yeah. However, there's a good side to that. Many late mornings. We worked, no joke, coming into the summer. Once school went out and coming into June when school came in, we were working. It was very common for us to work till like 10 or 11 o'clock at night, go home, come back at 8 o'clock the next morning and work all day again. And there were times when we were working till 2:30 and 4:30 in the morning and still leaving and coming back at 8 o'clock in the morning in order to get the car done to come. You don't want to be in that position because you're tired, which means the quality of your work and the accidents that can occur and stuff like that, and the refabrication because you made a simple mistake, it just complicates things, increases more time, more cost for that. That car, one of the things they told you is overbuild your car. Now, we had heard a horror story that there had been teams come that had taken 2 and 3 years to get through scrutineering. We were the first team out of Kentucky, and we did not want to be that team. It's a lot of money to come down here, and there are already people across the state saying this can't be done. High school students can't do this. We were bound and determined to prove them wrong. So we overbuilt the car, 1,246 pounds. But here's the thing, we placed 4th that year. Why? Because we never came off the track. Once we got here and we had someone help us adjust our brakes to where it would actually stop the car, it's a heavy car to stop. Once we got that thing fixed and we got through scrutineering, which, by the way, we passed the first year in a day and a half out of the 3 days, which was pretty good for us. We were running, and our only goal that year was to get through scrutineering. And then we passed scrutineering, and we're all standing around going, so what do we do now? We literally had to come up with new objectives and goals. We were like, well, let's just see if we can race without breaking down. On the 3rd day, we roll in and we're sitting here in 4th. And at that time, they used to give 5 trophies out. And we're like, we didn't expect to come home with any kind of hardware. And we're sitting in a position to where we can bring home a little piece of hardware, which would have been fantastic. And what allowed us to do that wasn't because the car was efficient. It was horribly inefficient. The wheels were out of alignment. The brakes were rubbing. It was 1,246 pounds. We had no telemetry that they talked about before, that you have to know how much power is coming in and going out. We had no idea. We were literally had a meter that said this is what the charge of the battery is. And if you know anything about this, when it's under load, it gets a different reading anyway. So we really had no information. We were just running, and that was pretty much it. So if you build your car to where it doesn't break down, I'm here to tell you, everything else, I promise you, you're going to do better than we did that first year. Stay on the track, and you're going to make yourself competitive, and you're going to have a lot more fun. Reduction in quality. I told you about the inefficiencies of the car. You're going to have it drastically reduces your quality of the car, and the negative aspects go on and on and on if you don't have these. Quality mechanical drawings improve. These are the benefits that you get if you will have good quality mechanical and wiring diagrams. Design and assembly is greatly increased efficiency. You can divide your system up. Let's pop all these up here real quick. You have huge savings and increased quality because you are not doing all that rebuild system. So you're not wasting a lot of materials. You can make your vehicle more efficient. And the second year we built, when we came back, by the time we came back, we had 50 different things. The students came up with 50 different things that they wanted to change on the car. What they determined was they had to rebuild the car from ground up, which they did. And the difference between the first and second year car, for those that saw the Bath County team between the first and second year, was night and day. I get so excited to watch a team come back their second year because the quality of their builds is tremendously, it's just so much better than their first year because you learn so much from the mistakes that you made the first time. Don't be afraid to make mistakes, just learn from them. Your safety, maintenance, and compliance. There are lots of rules within the rule book. By having these mechanical drawings, before you start the build process, you are able to check and make sure that it's in compliance with the rules. whether it be the roll bar system, whether it be the spacing for your safety shell. If you use Make Human, the app for that, which makes a human body that you can put in your measurements, and you take that little model of the person and put that in the driver for each of your drivers and people that are going to be in the car, you can actually then go into the CAD program and determine whether or not your spacing is appropriate around your drivers, your crush zones, that you have the appropriate tolerances for that. If you do all this beforehand, you don't have to sit there and guess or constantly keep checking as you go. You can actually have a pretty good idea before you start, and it saves time. Communication and coordination. When you do this, we started a process that second year that is what we call SOD, Simplicity of Design. We call it that because SOD is, it's an acronym for that, but we call it that because SOD is also the grass that's on the ground. And the idea behind that is that we build from the ground up, inside out. The grass grows from the ground up, and it grows from the inside out. And we do that, and the concept behind that is this, is that first things that they've told you you have to get are wheels are one of the most complicated things and difficult things for you to actually to find for your vehicle, because as I told you, it's going to determine things like your brakes, your steering, your ride, your rolling resistance. It's one of those things that just kind of affects many things on that. If you wait like we did on the first car and choose our wheels after we built our frame, we did it backwards. It causes lots of complications, and we ended up having to add a lot of things to the car that didn't need to be there in order to get these wheels that we found added to this frame. If you go the opposite direction of that, you'll find that your design is much more efficient. Then the inside out is start with your passengers and look at the rules and the guidelines for that, and measure out from there and get all of your measurements for that based upon protecting your occupants. You're going to have your safety shell, your roll bar, and your crush zone, and they're all dependent upon that person that's sitting in the middle. When you do this, the communication and coordination section of this, what I'm getting at is this. When we went to that, what that allowed us to do was to break the car into different sections. Suspension, the front end suspension and the rear end suspension and drive system was two different groups. Then we had another group that was focused on the inside out, which was doing the safety shell portion of that. And all they had to do then was communicate with one another on how they were going to connect those pieces to that safety shell for that. But it allowed us to take our large team and break them into smaller groups and focus just on those different sections of the car. But if you don't have proper CAD drawings, mechanical drawings for that, it's very difficult to do that because there's no blueprint for the entire system. Testing and design optimization. There are programs out there that will allow you to optimize and check your system as you go through, and Solid Edge has some systems for that, and there's a specialist coming later that can tell you for some of those, especially in the electrical system. Quality mechanical drawings and wiring diagrams provide accurate and detailed information about the design and layout of the car's components, which is critical for ensuring that the car is built to required specifications. And it improves assembly efficiency and reduces the risk of errors and delays. Division of labor. I've already talked about the division of labor. The thing that you need to understand up here is the accurate, detailed information about the components is critical for ensuring the car is built to specifications. When you go through scrutineering, hint, hint, I'm going to tell you this is what you need to do. There was a hint given to us the second year, when we went the first year, and we've done it every year since, and it helps. You have to turn in a portfolio, or I guess that's what we call it, correct? Portfolio, March 1st, scrapbook. You have to turn in your scrapbook, which is basically all of your mechanical drawings, your wiring diagrams, your specification sheets on things, everything about your car, and of course your registration fee, but everything in that. That book that you send in is basically your car. Now, they understand that there's going to be changes made from the time that you turn that in by March 1st till the time that you arrive there, and your captain and your advisor are going to go in and they're going to ask you, are there any changes? And you can say, yes, we changed the motor, or we redesigned this component here, and here are the updated pieces for like that, and you update your scrapbook there. You need a copy of your final scrapbook that matches your car exactly, and you need to take that with you to the scrutineering process. When you get there, I tell my students, especially because I have students that are basically new, you're going to be nervous because your entire goal is to get through scrutineering. And I trust me, they are here to get you through. They're not here to get a gotcha kind of thing on that. They're here to help you get through. But we get nervous going through, and they're liable to ask you, okay, so like in the lead acid days, you have a battery box that's required to have air circulation, and you have to circulate X number of cubic feet of air over a certain amount of time. How did you calculate this for us? And you're sitting there going, if you have your notebook and your calculations and things are in your notebook, you can flip that open, and lo and behold, it sparks the memory, and you'll start using that, but in reality, you'll probably switch over and just start explaining yourself because now the nerves are not there. When we get to our wiring diagram, I'll tell you a little story that happened for us. Cost savings and quality. Having accurate and detailed mechanical drawings and wiring diagrams can help reduce the cost of building a solar car by reducing the need for rework. It assists in ensuring that the car is built to the highest standards of quality and performance. It took us 1.5 years to build the first car because we were doing everything just by feel, pretty much. The second car, which the first car would go, I think we averaged about 17 miles per hour. It was just extremely inefficient. The second car that we built, I'm still real proud of that particular car, what the students did with that. That one actually would run 44 miles an hour. Wasn't the speed we should race at, by the way. Don't do that. It's not very efficient. But it was much more efficient, much more streamlined, much safer, a much safer vehicle. We actually took that car out on U.S. highways, running that car, and it was funny to see people down, you're driving like that, and we're zipping 44 miles an hour down through 60 over in the Moorhead, Kentucky area, and people are sitting there on their phone, they're doing this right here, and they're sticking their head out the window, going, what in the world just went by us? Your car, we built the second car in 3 months, during a COVID year. We were only allowed to have 2 students in the shop at a time. They had to be in separate sides and they could only be there for 2 hours at a time. But because they spent all their time at home and did the mechanical drawings and the wiring diagrams and they knew what the plan was before they walked in, their time was much more efficient. Our level of rebuild was almost practically none. So the cost of our car was greatly reduced, but the efficiency and the effectiveness of the car was greatly increased. I cannot stress this enough. The time that you think that you're wasting by doing that, it will far benefit yourself. You'll benefit yourself much more down the road. A painter comes in to paint a house. If they take the time to do all the prep work before they start, they can fly through painting the house. But if you don't do that, then you have to really, really slow down in order to cut in their paints, things like that. And it ends up taking much longer amount of time in order to do the job than it did if they had actually done the prep work. The prep work is not a waste of time. It actually speeds up, but you don't see it until the end portion of that. Safety, maintenance, and compliance. Quality mechanical CAD drawings and wire diagrams can help ensure that the car is built safely by providing detailed information about the location and operation of safety critical components such as brakes, steering systems, electrical, etc. It makes it easier to maintain the car by providing detailed information about the location and operation of various components, as well as instructions for performing routine maintenance tasks. That first portion, everything is about safety on this car. Do not sacrifice safety for anything. But when you do this, you can have efficiency, lightweight systems that are safe if you plan it out in advance. If you don't, one of the big problems we had on our first car because we didn't have that is we were constantly trying to fit around. I told you we chose our wheels last. Well, with the wheels came also our suspension system, our shocks, our brakes, our steering was all attached to that, and we already had a frame that was there that was not designed to accommodate tie rod ends, steering columns, room for the shocks and the suspension to actually move, and we were constantly having to modify or do things that were not ideal for that, and we had to add additional materials in order to do that, which is why the vehicle ended up so heavy and so inefficient in design, is because that wasn't taken into consideration at the get-go. So if you'll do that, it makes it not only safer, but much more efficient for you. Yes? Please.
On a race, I can basically say whatever I'd like to say to you guys, including some stuff that will give you a competitive edge. I will not share these same things when we're in the middle of an event. Number one, scrutineering, what I have seen teams that I have had to send home that didn't make it through scrutineering spend 4 or 5 hours redoing electrical schematics and mechanical drawings to match their car because they couldn't get through the station because the stuff that they submitted wasn't even close to what they brought to the event, and the judges were holding them to that. So, number one, that's an area where, I mean, a team maybe spent almost 10% of the available time in scrutineering working on updating paper. And that was one of the things that contributed to them not getting in. It's more than one team that I've seen this happen to. Number two, Brian talked about the safety aspect of this, crush zones. Who here has actually read the crush zone rule? Isn't it really ambiguous and a little bit challenging what we're actually asking for and what you see in the rule book? I mean, I wrote most of that, so I'm going to say it's a little ambiguous and challenging because when you're trying to write rules like this, we're trying to give you some freedom to still design your car without saying you have to do it exactly this way. And it's really hard to communicate that through a set of rules. If you do your drawings ahead of time and you have a design ahead of time, you can approach us with that and say, hey, is this going to get us through scrutineering or should we change something? That's option one. Hint, that's the right way to do it. Option two is you don't pre-design it. You build what you think is going to be okay at the last minute, and you bring it to scrutineering, and we ask you to cut and weld on your car, which eats into a third or half of the time that you have available for doing work during scrutineering to try and pass your car. And that has actually caught many more teams. Now, typically that's not the only problem that a team has when they get to that point, but if you're looking for hints about how to survive this and how to get through scrutineering, this is key, because if you CAD it up, design it ahead of time, you can send it to us and ask, will this get us through scrutineering, or is there something we need to do different? Is this what you were trying to communicate in the rules? This is what we think is going to be okay. Is that correct? It's super easy to write one of those emails. Admittedly, sometimes it takes me a few days to kind of help and get back to those, but we will, and we'll tell you and we'll work with you on it. That's saving you like potentially half of scrutineering, reworking your car just by doing that design, let alone all the other benefits. So again, if you're looking for a quick hint and cheat to get through this, just design it ahead of time. And once again, talk to the event if you have questions. We know some of these rules are hard. We get put in a hard place because we want you to have the freedom to design a car multiple different ways. If I said in the rules, you specifically have to do it all this way, every car would be exactly the same that came here, and that's not what we want for you. So the trade-off is sometimes it's hard for us simply through writing in the rules to communicate what we're after, or tell you, hey, you know, that wasn't quite what we wrote here, but it's within the intent and it's good enough. We're okay with that. They use this email as a waiver to get through scrutineering. That absolutely happens. We give out a lot of those every year for the teams that talk to us. Because again, you're complying with the intent of what we want to do. I just wanted to reinforce that point, how valuable that can be.
Oh, no, you're perfectly fine. The last one, help ensure that the car is compliant with relevant regulations and standards by providing detailed information about the design and layout of the car's components. That last part, the layout of the car's components. I told you a minute ago that we went and it saved us, that booklet saved us that second year because we had a young lady that was primarily responsible for graphic arts and fundraising and things that were not actually building on the car. She had a different role in the thing. She did help with some fabrication and prep work, like fabrication of pieces, but she didn't do anything with the electrical system at all. Well, she went to scrutineering that year and she went to the station for electrical, which she wasn't really supposed to go for that, but she ended up there. And lo and behold, everybody else was there, knew the electrical system inside and out. And here we had one extra person that was there that did not know the electrical system. And guess who they asked a question about the electrical system? But this young lady. But they had their notebook, our scrapbook, right? And it matched the car. One of the things that you'll see in just a moment is we were very specific on how we did the wiring on our car. And they said, okay, so you have a switch here that does X. Can you trace that on the car for us? The nice thing is our wiring diagram and our car looked exactly the same. So she didn't know anything at all about that, but was able to completely trace that through the car because they were the same. So just an FYI, you might want to make sure that it does that. You'll see a picture here in a moment. I'll give you a demonstration of that. Communication and coordination. Quality mechanical drawings and wiring diagrams serve as a common reference point for the team, helping to facilitate effective communication and coordination between team members, advisors, and industry partners. All three of those are critical in order for you to get your system put together in a timely fashion. Test, design, and optimization. Quality mechanical CAD drawings and wiring diagrams can help to test and validate the car by providing detailed information about the design and layout of the car's components and allowing the team to easily identify any issues that may need to be addressed. You heard a moment ago that someone had a short on their, they had a ground fault on their car. One of the things that we did between the first year, we went the first year, we ended up with the same thing. We had a low voltage current going through the vehicle, and we could not find that. It took us forever to find that. I told you we got through in a day and a half. Well, about a half a day was spent trying to find this floating ground on the car, and we were afraid we weren't going to be able to find it. It ended up being that we had a turn signal system that clamped to the steering column, sleeve, which was a metal clamp, and the steering column sleeve was a metal sleeve. And even though that clamp was going to a plastic piece, it was getting a residual current from it and transferring it to the car. Once we put an insulation aspect between that, it took care of that. But it took us a long time to find that. And because our wiring system was not set up like we now do it, it was that one of those, okay, we're going to put it in, and it looks fairly neat, but it's not great, and our wiring diagrams did not match that. We had done the typical kind of new first year kind of thing, which was not a good thing to do, and it took us a long time to do that. We learned our lesson from that. We're trying to tell you up front, this is a collaboration, not a competition. We are trying to tell you all of these things so that you don't repeat the same mistakes that we do, that you can learn from them and actually make better products, and then challenge the experienced teams to make better products. Quality mechanical drawings and wiring diagrams can be used to manage and procurement of materials and parts by providing detailed information about the components required to build the car. You have a project manager, or at least hopefully there's somebody working along that lines that's doing the project management for your vehicle. You have an individual that's trying to get it, maybe your advisor, but hopefully it's also students working alongside them. You need to get materials in a timely fashion so that you don't have a delay in production. That was another reason our first year why we were so slow and took a year and a half to build the car, is because we were constantly building and getting to a stopping point because we didn't have materials sitting there. It wasn't that we didn't have the money, we just didn't order them in time because we didn't have anyone doing that. It was because we also didn't have a plan, so we didn't know what was needed next. A few examples. Bare basic CAD drawings, and I do mean bare basic. You'll notice on this first one here, if you send them in black and white like this to them, you are very much going to have to go through and label this very clearly for them. They want to be able to see your roll bar. Where is the roll bar? They want to see what you're determining is your safety shell. What portion of this is your crush zone? Because there may be a lot of other things that are actually attached to your car that are not those three critical components. You need to be able to identify them. You need to be able to identify the clearances for between the materials and the personnel that are in that. And I'll show you some drawings in a minute. What we decided on one aspect was we color coded, but that color coding doesn't do any good because that's basically the windows, the windshield, and the wheels. Now let me show you something that's a little better. Oh, I'm sorry, one big thing before. We got so detailed in our second year that we literally CAD'd out each individual component on the car. And we did it by, we had the components sitting there in front of us. They measured them with calipers and drew out those pieces so that when they put them in the assembly for the car, they knew whether or not it was going to fit or not, because it was literally down to the fraction of a millimeter in there for that. And so the idea of putting something in that's a rough estimate for something wasn't the case. They literally CAD'd them out. And a lot of these things, you can actually find the CAD drawings already done for you. And so if you take them and then put them in when you do your assemblies, and your advisors can show you how to do that if you don't know how to do that. And there are tutorials on the solid edge system for doing that. You'll notice that, who can tell me what that this piece is right here? What is this? Anybody know? That's a master cylinder, and that is an MCP master cylinder. I can tell you right now that's what this is here. This caliper that's up here is a wheelwood caliper, and they are to the exact sizes as close as we can possibly get them in a CAD drawing to that. This steering system down here we got from the off of Amazon, and it's to the exact size that they're using. The rims are the same size. This is what's kind of where you're wanting to go. In this drawing, you'll see that there are three main colors in here. You'll notice that there's a human person in there. That the program that you can use for that is called Make Human. You literally just measure yourself out, put all your measurements in, and it will make a character for you. Now, they're going to make it standing like this, and you'll have to take it into something like Blender and bend it into a seated position. But you can actually take, for each of the people that are going to be in the car, and slide them into your drawings, import them in, and you'll actually be able to then determine, measure from the inside of your vehicle to that person to see whether or not you're going to have your clearances and whether or not you need to put a cushion in like that. The gold on this right here is the roll bar. The red is the crush zone. This one has a little more crush zone than is now required. And then the black is actually the frame. This is a side view. You'll notice that we have measurements for our PV array in the top. It says 4.94 meters. You're authorized only 5 meters, and that's it. Do not go, your lat's 5,000 millimeters, by the way. Do not go 5,002. You'll be taking a saw to your PV array and chopping something off. I heard a story about somebody that was at 5 meters and 1 centimeter, and they were literally having to chop off the end of their PV array because it was too long. I got an email. There's a Kentucky team. We're helping other teams come, and they sent me an email and said, so we've got this right here. Our solar panels are 1,810 millimeters wide. How serious are they on the measurements? I said, very. You need to take off. You're going to be cutting those off if you don't fix it. And so literally I'm going over on February 10th to meet with that team to see what kind of reconfiguration we can do with their PV array. Do not push the envelope for that. Always leave yourself a cushion for that. You'll notice that in here, when I put the driver in, we actually measured and we know how high their eyes are from the ground. We know that we can put in here and make sure that they have that 10-degree clearance. There are so many things that you can do that's going to save you time and heartache by doing it in your mechanical drawings, rather than getting to scrutineering and finding out that something is not compliant and you having to reconfigure something. Something as simple as where that solar array is on the top, not getting your 10-degree compliance, causes you, it's a cascade effect that occurs. One thing affects another, which means you don't have time to fix. You need to do these things at home. Top view. We're going to come back to a top view in a minute. By the way, if you don't know, the maximum width for your car is what? What's the maximum width? What is it? 1.8 meters, right? That's your maximum width. If you'll notice in the very front on the far right, it says 1.71 meters. What is it measuring? The width from the end of the spindles. Guess what they're going to measure? Whatever part of your car is sticking out there. Everybody always thinks, oh, it's the body or it's the outside of the wheels. It's whatever you have sticking out there, that's what they're going to measure from. Your heights and everything like that, keep that in mind. Now, you can't go in and they're going to tell you can't put fins, and like the two-seater, the electric solar has minimum heights and minimum widths, and you can't put like little stingers coming out, poles coming out the back end. It's a safety issue. Can't put a fin like a big shark on the top of it to make it high. You have to be a little more realistic for that. Don't try and fudge those rules. It didn't say I couldn't put a fin on it. Well, it does now, because people have tried it. Rear dimensions again. I'm going to finish with this, and I'm going to finish with these 4 pictures I have for you, and this is a precursor to this evening. If the drawings there's a gentleman going to be here from Solid Edge that's going to show you how to do the drawings. If you have any questions, feel free to ask us. We can do that. Most people can do the CAD drawings, have somebody in their school that can do that. This next portion is the wiring diagrams. Now, typically, they mentioned earlier, the gentleman that spoke before me was talking about different types of wiring schematics. This is a typical kind of thing that you might see if you were doing wiring diagrams or schematics for that. We chose not to do this because we didn't find this very helpful for us in actually doing the car. We chose to do this. Now, don't get overwhelmed by all the wires. They're just there so that we could individually see them and trace them on the car, and they are actually color-coded to match the wire colors in our car. So the nice thing is, I told you that young lady that didn't know anything about the electrical system. She had this drawing. This is the actual drawing that she used, and they asked her over here where it says the switchboard. Does this have a light? Oh, sorry, I turned it off. Right here where it says switchboard, there was a switch here, and they said, this switch, can you tell us what it does? And because when we opened our car, the wires were laid out neatly and everything like that, we actually ran them through conduit. She could trace that all the way back to the back lights that were back here and how they came back through the entire system because she had this drawing and the car matched it. This is not complicated to do. It looks complicated, but I promise you, if you come this evening, in a very few minutes, we're going to show you how to do this, and we have some handouts for you so you can take back home. You don't have to remember everything for that. So we'll have some handouts for you to do that. This is just the low voltage wiring diagram for that. You'll notice that on this, all of the wires are on the left-hand side. We made a conscious choice to do this as well. If I go to the high voltage, on this one, you'll notice that all the wires are on the right-hand side of the car. This is the high voltage. We chose to do this because we didn't want our high voltage and low voltage systems running on the same side of the car. And the way we ran on the track for that particular year is you exit on the left-hand side of the car when you go to get out. If we were changing drivers, it's like that. So that way our drivers never had to step across a high voltage line. Now there are other things going on, that rules that have changed since then, that kind of negate this need. But we did this on purpose so that if it was a high voltage system, we know to go to that side of the car and pull the panels off there. If it was or on the right-hand side, if it was a low voltage, we went to the left-hand side and pulled the panel off there. We weren't tracing them all over the car. In addition, electrical efficiency is going to be determined based upon a lot of things, not the least of which is going to be how long of wiring runs that you make. The shorter you can make those and the closer you can get your power sources to the actual place that its load is going to be, the more efficient your system is going to be for that as well. This up here is a low voltage example of a four-seater that we started the year before. You'll notice that this amount of wiring and the wiring this are significantly different. But the only difference is, see this section right here where the red and black is? This one here has more wiring in it because we chose to put a switchboard here, and it had to come back to the low voltage battery and come, so it went both directions. So that's the only reason this one has. If you look at the next one, it's been simplified because of our location where we decided to put the switch box is actually more centrally located, and it uses a significant amount less wire for this right here and does the exact same thing. So your placement of your electronics will matter. And by doing your mechanical drawings, you'll allow for places for that. Doing your wiring schematics and wiring diagrams will allow you to then determine where is the most efficient place to set those kinds of things. Keep it simple. Einstein once said, make everything as simple as possible, but not too simple. All right? So you need to make it as simple as possible to get the job done, but not so much that you sacrifice safety when you're doing that. There is the high voltage system for a four-seater. Any questions?
I guess let me just add a comment real quick. With regard to the wiring diagrams, I totally use that in our cars too, to be able to find the wires, and we even use numbers as well as colors. But I'll say that having a logical electrical schematic that has that more simplified look and how the components wire together is useful as well. And so, having both of those things is good, because then you could really see logically how the components are hooked up together, not just physically how they are wired.
If you are, for those of you especially, I would definitely concur with that. Those that are, especially that are doing like the advanced or the cruiser division or anything that's going to have complex electrical systems in them, you really need to up your game in that. And I'm not talking about just the appearance, but as he was saying, your wiring schematics. You actually need to do some research if not familiar with that, and you need to put those together because those have some different kinds of technologies, as Mr. Pitts mentioned earlier, that when you're putting those in, you really need to know some more specific information. What we showed you here is just general, this is where things are. There is nothing in here that's telling you any kinds of fuses or relays or any kind of high-end electrical systems that you have or components that you would have integrated in there, especially if you're making, some people actually make some of their own components for that as well. If you're doing those, you really want to make sure, if you're not buying something off the shelf, especially if you're going to be custom designing something, which is very possible, you need to have actual schematics for those because they're probably going to be asking for them, and they want to make sure that those are actually safe to run. You do not want to mess with the electrical system when it comes to your car. One, it's a main driving system, and two, it's a major safety area. Any questions?